Okay, guys. So I'll just go with the on project. Okay, for see, like this we have so many applications, guys. Whatever you people understood, right? Like this we have so many non-embedded applications. So I'll just share you the notes in the WhatsApp group. Yeah, in the WhatsApp I sent you the notes. So I'll just let you know what exactly it's all about. Yeah, I have a small request. So please, only the internship candidates access this. Don't share with your friends. Of course, for everything there should be value added from your end as well as from my end. So since you enrolled and you paid for this internship, you are eligible ethically as well as professionally to access this material. People who are not paid, don't share to them. Anything comes free, there is no value. That's the reason. Yeah, so this is a circuit design application. So here we give all the information how to enable the libraries, how to create a project, how to add a components, criteria to select the components, and how to convert from schematic to PCB. Okay, post PCB, what and all things we supposed to do, that is here, that is going to be done in the offline classes. Okay, regarding the circuit designs, guys, we have so many circuits here. You can observe we provided many circuits and circuit titles followed by the circuit diagram also. So this is a bridge rectifier circuit diagram followed by its component. So if you want to get this component, you can type this name in the component window. If you want this component, you can type this name. If you want this component, you can type this name. Certain whatever it is mentioned in the component window, sorry, component column, whatever it is mentioned in the component column, those names if you type in the library, you will get a certain component. Okay, that is how it is done. So we have a many thing. Motor driver is there, we have a relay circuit, we have the LDR circuit, we have power supply temperature sensor circuit. Like this many circuits which are not embedded, okay, which are not having any kind of microcontroller included in that. Those circuits are individual circuits are available here. You can like practice these circuits. Okay, and you can let me know if you're facing any issues. Clear? So just wanted to cross check once again if anybody is facing issue in the PCB design. Whatever we did, it is not only the PCB design, guys. We have many more concepts. So whatever I said is just like the basic level. Whatever you did understood now. Any issues in that? Anybody is facing challenges? Okay. Yeah, then I'll start with the next project. Embed system PRJ. See now, same project, whatever we did. So we did with the without embed system, right? Same project, if we do with the embed system, of course, that is also possible. It is not something like it is not at all possible. So what I'll do, let me check. Is there any duplicate option? Is there? Okay. Yeah, I just duplicated this. So here in this project, without any kind of microcontroller or microprocessor, we directly gave the sensor result to the load, as you already know it. Okay, same project, instead of using directly from sensor to load, where I don't have a multiple intensity setting. Here we can't set the intensity for multiple level. Once it is hard coded, it's done. So to change the intensity, guys, you can also use a concept of potentiometer here. Okay, so this will helpful for you to change the intensity. You can change the intensity by using this. Okay, before that, let me check how exactly this virtual potentiometer works. So I'll take a multimeter. Will it give the multiple voltage reading or not? We have to check. Just for demo purpose, I'm doing it. That's the reason I'm doing the random wiring. Yeah, you can observe here. It is giving the multiple voltage range, right? Sorry, multiple resistance range. Sir, I want it to be having a multiple level of intensity requirement. So I should give the option to the user to set the intensity by themselves. At what intensity they want to change they want to turn on or turn off the light. In that case, you can use a like this potentiometer along with existing circuit, and you can, instead of 250 ohm kilo ohm, you can make it 250 ohm, because as we observed, when we are providing in a kilo ohms, it is not doing the task of controlling, right? It is directly allowing the bulb to turn on. So now I gave it 250 ohm, nothing is happening. Sorry, when it is like this, it is 0 ohm. So when I rotate it only, it is considered as a ohm. See now, let me use a multimeter parallelly to check what is the resistance we are keeping now. Yeah, this is the 1 point resistance. See, now we are keeping 130 ohm resistance. For 130 ohm resistance, so whenever the light is, okay, because of multimeter. Yeah, so let me make it like see now. So I want something like, whenever the intensity is this much, I would like to turn off the bulb. Till that point, I want to turn on the, I want to turn on the bulb. From here to here, I want to turn on the bulb. After that one, I want to turn off the bulb. So you change this in this particular value. Yeah, key, like I'm keeping it like this. Now you observe. So whenever that point is crossing, then only it is turning on the bulb, turning off the bulb. So till this intensity, it is turning on the bulb. Sir, I want for this intensity, I want to turn off the bulb. Means increase this potentiometer slightly. Yeah. See now, below that it will turn on, above that it will not turn on. So like this, instead of making it like a hard coded resistance value, if you use a potentiometer, you can set the intensity. You can set the intensity. So in that scenario, whenever we want to do like this, so I'll show what changes you're supposed to do in the designs for PCB real board. So first I'll show in schematic. See guys, in schematic, because of this particular component, it hard coded. So I delete this component. Okay, I delete this. I go to add component. So there is a component called as a preset. Again, in the potential variable resistor guys, we have a different type. So you can observe here. We have a PCB mountable potentiometer. Yeah, this diagram can give the good clarity. So these are all the high power potentiometers for high power applications. So you can observe here we have a preset pot, which is a PCB mountable. We have a linear pot. We have a sliding pot. Like different potentiometers are available. This is also trimmer pot. This is also PCB mountable. This is also PCB mountable. Okay. So like this we can use, like generally in our demo applications we're going to use like these potentiometers. Okay, you just type preset here. If you type preset, you'll get it. This is a single line potentiometer in the same line. It means this type. Okay, and one more, we are having a 3-pin potentiometer that is diagonal, either this type or this type. Okay, so again you can observe the distance between the length, distance between the two pads. So this is less distance is there, this is more distance is there, because here this potentiometer has a less distance between the pads, whereas this potentiometer has a more distance between the pad. So according to the, this also potentiometer, this also potentiometer preset. According to your requirement, you have to select. According to the selection, you have to select this pot. And what we are going to do here is we are going to use like this. One pin we are going to connect to this. One pin we are going to connect to this. And one pin we are going to connect to the ground. So based on the, I think ground is not required. We are not supplying the voltage. We want only the variation in the resistance like this. Or you can also connect, interconnect these two. That also works same. So now this is having the variable potentiometer. So now what I supposed to do? I have to first unroute all these things. Okay. Then from here I have to use a forward design changes. So when I do the forward design changes, you can observe. So whatever previously we had a component, that component got replaced. Now we are having like this 3-pin component. I'll rotate and I'll place it like this. Anyhow, we have a space. I'm getting error. Now also I'm getting error. Okay. A minute. Okay, so now three potentiometers. Okay, let me do one thing. I'll rotate this one like this, so I can push it here. So after this, I'll do the auto route. Tools, auto route, all nets, route. Yeah, 100% completed. So now you see the 3D view. Yes, this is with the variable intensity. Understood? So like this, you can increase the features of your project. If you have a proper electronics knowledge, you can do this. So simulate first in the Tinkercad and understand the concept. Then select the right component in the PCB. Then do the task. And whatever we did till now, we got only up to the level of 60% of output. But this is not 100%. Why? Because we are not yet done with the hardware. This is just a virtual concept. Everything virtual now. It is not a real hardware. So once we print it, once we prepare this board in reality, then only we can assure this board is ready for further manufacturing. See guys, actually you should do small product like this and install in your home. Okay, so keep like it, see in this one only this LDR somehow you have to make it exposure to the light. We can keep it near the window, or like you can extend the wire and you can keep it near the window or somewhere. This has to extend, this has to be visible to the light. Remaining everything should be near the any one place. Understood? So like this you should learn the concept with respect to the product development. Any small project you do a PCB for that, convert into product, convert into the motherboard, then fabricate it, then assemble the components and make it a standalone. See now in this one there are no loose connections. So your job is only being a user, you are going to deal with only these two screw connectors. You give the power supply, you connect that one to the load. Bulb will have a two wires, right? Bulb two wires will be connected to this. Power supply two wires will be connected to this. Remaining everything will work as it is. Yeah, like this, even the small concept. See, until unless you get a complete idea, sir, I know right and left of a complete PCB. Then no need to do a PCB for every project. But until unless it is better if you do it, because you will get a much good practice. And after auto routing, you have to do this small editing, guys. Whenever it is very near to the pad, increase the distance between the pad as well as the tracks. And also, as I said, if there is a continuity of the tracks through the pad, try to avoid it. If there is an option, please avoid it. Make it like this. So if you drill the hole also, this connection will not get disturbed. There is parallel connection. Here also same thing. See here also same thing. And here the thickness of this pad has to increase as we discussed yesterday. Yeah, see, no errors found. Like this small editing you have to do. If you do the auto routing, manual routing means you are only handling everything, you can do it. If you're selecting auto routing, a small editing is required like this. Okay. And also whenever you're moving any component, if you're feeling if you're facing any issues, press escape. Automatically it will come back to its position. Okay. So this is how you should reach all projects. I want you to practice like this. Up to this level you have to reach. And I know since I'm an expert, we already have the experience with this particular technology, we do it in the easiest manner. For you, it may be a little bit hard cake, but everything is all about practice. Unfortunately, in the colleges, they are not covering such topics. They are just going with the concepts. That's the reason practical knowledge lacks there. So this is a real practical approach towards the product development. Whether you develop a AI ML product, whether you develop a IoT product, whether you develop any type of product, this technology is common. The printed circuit board technology is common. Whatever product you develop, because the circuit board is giving the physical support for the component placement. Okay, so this is giving the physical support, and it does not expect like it is not having any kind of knowledge what type of application this particular component is going to do. It is not having any idea. It is not having any kind of idea what this is doing, what this is doing. It's all about its job is to connect from that component to another component as per the expectation. That's it. So that's the reason in many colleges I suggest let the student design a PCB for their project. And one challenge that students face in the PCB technology is the cost of the fabrication. See, generally what happens, guys, if you give this particular board for fabrication, you may not get a one or two boards, because the industry, the manufacturer, like us, we won't accept only one or two boards orders. Generally, we tell there is a concept called the engineering charges for this. The first thing is you are going to bear the charge of around 2,500 rupees for engineering setup. Engineering setup means generally the diaphragm and many things they are going to manage for this in order to develop a PCB. So engineering setup, then followed by the board, based on the board size they are going to charge. Okay, and in a tray there will be a filament tray will be there. In that tray how many will sit, that much minimum they will expect. So it means if you want to do this particular project with the industry graded board, at that time what happens, you have to invest at least minimum 2,500 rupees minimum charges. And because of this reason, many students what they will say, just for a one small experiment, why we supposed to invest? Like we can't invest 2,500 or 3,000 rupees only for one experiment. If any kind of mistake in the connection means again new circuit, again new 2,500. So that is how generally things goes. That's the reason many participants will not take up this particular task. But actually there is a we prepared one kit for the students. Even in the Amazon or like in online also you can get if you just mention a PCB etching kit. But I'm not sure whether they will give you the industry standards chemicals or not. PCB etching kit. So if you just mention PCB etching kit, you will get a many kits like this. So using that kit, you can develop a motherboard without any kind of industry support. Okay, you can develop a motherboard without any kind of industry support, and with our kit especially, at least you can you can perform a task. See here in the from the Spark Fun, you have that kit. I think it is a PCB fabrication kit or something else. It is something else, not PCB fabrication kit. So with our kit, you can at least fabricate 10 to 12 boards minimum. And you can fabricate single board. It's not compulsory you have to fabricate one board only, like a 10 numbers, 20 numbers, nothing like that. You can fabricate even the single boards, like you do the R&D, you fabricate it. If it is not changing, again fabricate. with your existing homemade components only you can do many tasks. So like this small investment you have to do, and you should have that habit. You should get that particular like habit of fabrication and everything. Then what happens, like you can easily see you can easily go for the real time product development. And obviously I'm sure guys, like everything you won't get from the college, because college is purely made on the syllabus. They won't focus anything out of syllabus. And they may ask you to go for a training like this, but in the inside the college it is very difficult to arrange everything, because maintenance is challenging, followed by investment. Many challenges are there. So today we are the entrepreneurs and we are leading the company because of this extra investment. So more than at least that's the reason always I will give this example. Um, See, buying a elephant is not important. Buying along with the buying a elephant, buying the chain for that elephant is also very important. If you just invest a 10 lakh rupees and you brought one elephant and you are hesitating for 10,000 rupees chain, that elephant will create a damages. Same way you are investing so much amount of rupees to get a degree certificate, it may be MTech, it may be BE, anything, you are investing so much amount of rupees for a degree certificate. But if you are not investing for skill improvement, don't expect everything from the college, don't expect everything from one source only. Please invest by yourself like this. Whatever fees you paid now for the internship, whatever fees we are asking, like whatever like components we are asking you to procure from the Amazon or anywhere, it is not compulsory from our company only. But what I suggest is, please be in this domain, in this particular thinking. Invest more, you invest more, you returns get returns. Clear? Okay. But only investing is not important, you should practice them. You should have a agenda while investing your money. Okay. So when you do certain tasks, you will get a really good knowledge. Okay. So this is what the fabrication this is what the small product you did now, without any embedded system, any kind of programming. So now we'll move to the concept of programming. So anyhow, it's already 1 o'clock. Just I wanted to know, are you comfortable up to this level? One by one. Chetan, Chetan K, yeah. Sanmaya, yeah. Kruti, okay. Hemant, yeah. Purvika, Chetan, yeah. Okay. So hope you people learned this PCP technology, which is new compared to your these many days content what you learned in the lab. And of course, guys, unfortunately, we say it as a lab, but in the lab everything is ready made. You just go and connect according to the circuit diagram. To be honest, more than a developer, you are just an operator in the lab equipments concept point of view, your educational experiment point of view, because it's just an operator. Like now also, of course, I do agree. I gave you the circuit diagram. I taught you the PCB design, and exactly however I designed in the same way. If you design now also, you're operator. I won't agree that when you are a developer now, because you are simply following our whatever instructions are given. You are following. It's good. First time, it's really good. You have to follow the existing instruction. But what I want from your end is, let me consider I don't have a like this rectangle space in my like a product. This is a part of the product, it is not a complete product. Example. So now I don't have a rectangle space. Now I will give the space for you. I will give the exact dimension. Within that dimension only you have to fit it. Okay. Let's extend the PCB part a bit. See now. I click on this border, I am getting a 7.9.78 into 4.48. Okay, so around 50 I am getting, right? Sorry, 10 into 50, 10 into 5, 50 square centimeter I am getting. That's okay, no problem. But sometimes we will not have an option of rectangle placement in my cabinet or project somewhere. In that case, I don't want it to be rectangle. I want it to be in a some other shape. In such cases, you should again go for a rearranging the component. Example. Okay. So you can observe now. So I don't want this to happen with the rectangle. I want it to be something like a square or with a some other shape where I don't have enough length. I have the enough width. At that time, what I will do, I can bring these things here. Yes. Now you observe the screen. So now I change the design. Now I'll do the auto routing. Tools, auto route, all next, route. Okay, 100% I got the auto routing. Now you observe the screen. I'm going to reduce the board size as much as possible. Slightly I'll move it because it is giving the trouble. Yeah. Now I can reduce the board, still move, still move. Here also. Here also because of this potentiometer I am getting the extra space. Let me reduce the board here. And I'll reduce the board here. Yeah, so now this is what I did. So now let's see. So I am getting 7 into 6. See, here you can observe 6.45 into 5.95. 7 into 6, 7 6 yeah, 42, right? So first 42. First it was a see, just now before this we did 10 into 5, 50. Now it became a 42. 42 into zero point 0.8. Now it is 33.6 minus 74.6. So we saved 41 rupees per board. right? Just now we made it 10 into 5, 50 into point 0.8, that is 40 rupees. Now this is 42 into point 0.8, that is 33 rupees minus 40 rupees. We saved another 6.4 rupees. Understood? We saved another 6.4 rupees because of the proper placement. So this is what exactly required, guys. Every time if you are having like a requirement, like the requirement is to save the space, save the money, then you can do that. You have an option here. See, now this is also 100% no errors. So let me check with the errors. Is there any errors we are facing? See, no errors found. So previously we felt okay, that itself is a good design. Now if you observe, compared to that, this is more good. See, understood? It's all about something like, okay, you were arranging the building like generally, even though we have a 30, 40 or 800 square feet of plot, if the building is not properly planned, it won't work properly, right? See now, a small square shape of board where the cost is reduced compared to first one, where is 74, where is 42, and where is 33.6 now. So more than 50% we saved the cost. So this kind of approach I want from your end. Only following my words is not important. You should also implement your knowledge. Okay, your way of arranging the components and your way of increasing the reducing the price by reducing the board size, that is also required actually. Then only what we can do is, this is very simple board, guys. It is not having much components and it is a single layer board. We have many concepts, two dual layer, two layer boards are there, many are there, many things are there still. And see here, just because of this particular but we can't reduce less than see, if I want to make it like lesser than this size, I have to bring it up to 5. That means up to this level. Up to this level I can't bring. That's the reason I'm not because relay itself is having that much size, right? We can't bring less than this. This much is okay. You see, it is a different style now. Okay, like this also you have to think in this angle also. Is there any other further reduction can I do? Can I go with the more amount of space and save like my price reduction, more less space consumption? All these things, if you consider, you will become a perfect product designer. See, on top of this, whatever we did till now is a okay. Simulation is working, motherboard is ready. Let me consider components also ready. On top of this, next concept is about the soldering. That also has to be done perfectly. Then testing. Okay. Then finally packing it in a box. That is the outer case design. That is also the next stage. Understood. So I want you to think in this angle also. I know it is a very small project, small circuit. You may look, okay, sir, it's a simple concept. Why so much things are getting covered in this topic only? But the concept is the technology, whatever you're learning is not simple. It is a important technique. And always practice the tools with the simple experiment. You will become expert in tools. Later point, that experience will helpful for the complex experiments. So if I start with the big motherboard design now itself, means it will completely tell, sir, PCB is not my cup of tea because it's very complex. Of course, when we go for a motherboard design, it look very complex. Now only will tell, sir, it is not my area, so it is difficult. See, chipket, the design, whatever they did, Say if I taught you like this design now itself, means you will definitely run away from this technology, because complexity is like this. See, our board is this, whereas the higher level board is this. So we may not be able to do it now itself, but practice the technology with this particular tool. Practice the technology with this particular experiment. Okay. Any doubts in the today's session? Okay, but I want the assignment to be submitted, guys. You have to practice. Tomorrow I'll start with the embedded system and like programming come into the picture. That is again the new concept. At least this is a artwork. You can easily do some magic, but if it is a programming, means you don't have any kind of options there. It is made by the instruction set. It is made by the rules. You have to use it in same way. Okay, that's the reason. Both the way you design it and send me the assignment, I'll go through the assignment. You can send just an image. This image is enough for me. Anybody is facing an issue with this software, please let me know. Anybody facing the issue with the assignment, sorry, the software license or anything, please let me know. Okay, can anyone, will everyone do this particular task and send me? I want it in a square shape. Anyhow, I will upload the today's session content in the YouTube channel and send you the link. But I want it to be in this particular shape. Okay, do it and send me. Tomorrow again we will meet. Okay, and also anybody is having the issues, it is not compulsory in the meeting only. You have to ask. Sometimes people hesitate for that. You can you can just text me through the WhatsApp personally. I'll guide you. No problem. Yesterday one or two candidates did it. We supported them. No problem. You can do it. Okay. Ultimately, I want 6, 7, or 10 members to be real techies. Really, you should become a technical experts in that internship topic. That's what my agenda. Sure. And also please inform to your friends, because less number of participants is very difficult for us from the like a time investment point of view. So inform to your friends, somehow refer and bring more candidates so we can good develop a good projects. Okay. Okay, guys, then see, we'll meet you tomorrow in the meeting. We will cover the further topics. Bye. Thank you.